Okay, so this is part 2 of our exponential equation notes. So we started with the idea that we need to make our bases the same, and then we can set our exponents equal. It looks like 5 and 125 are not the same, but I can write 125 as 5 to a power, and that power is, it's 5 cubed. So once I've set that up, I can kind of ignore the 5s since they're the same. I'm trying to get 2x minus 7 equal to 3. I'll add 7 to both sides, and I'll get x is 5. So the idea again is watch for those bases first. Our next example, similar idea, our bases don't match. So before I can set those exponents equal, I'm going to have to match them up. And I know that 3 is going to stay the same. But I need to figure out 3 to what power equals 27. And it's 3 cubed. So what I'm going to do is change 27 to 3 cubed. And then it's still all being taken to the 2x minus 4 power. Okay. Looking a little busy on that side, the 27. What we need to make sure we do is this 3 here is going to be distributed to each part of the exponent over there. So our left side's staying the same until we have the same base and everything's been distributed. So now instead of having 27 to the 2x minus 4, we're going to have 3 to the, and then you multiply 3 times 2x, so 6x, and then 3 times negative 4 is 12. Once the bases are the same and we have distributed it to both, that's going to be the biggest thing to watch out for, the distributing. We'll get 2x plus 4 equals 6x minus 12, and then it's a 2-step. So we'll get 4x is equal to 16, and we'll get x is equal to 4. So that first step, converting so you have the same base, is going to be really important. Then our last step, last example, I'm looking at something kind of busy, and our bases definitely do not match, so that's what I'm going for. A lot of the time for these questions, we're trying to get to like a common base, and we're usually trying to get 2 to the something, 3 to the something. Sometimes it's 4, sometimes it's not. It's usually 2 and 3. So if I look, 64 can be written as 2 to a power. Can 256 be written as maybe 4 to a power? We'll find out. Okay, so if we're looking at 64, I know that 64 can be written as 4 to the 3rd power. So I'm replacing that 64, and it's x minus 2. Then it equals, and if we see that fraction, that means I'm going to have a negative exponent. So if I'm going to convert it, it's going to be negative. So to figure out 256, it looks like it's 2 to the 4th, 4 to the 4th. Sorry. And because we have that fraction, that's the negative sign here. And then it's x plus 12. And just like our last example, we're going to take those exponents and distribute them. So I'm going to take negative 4, distribute. And then after my bases are the same and I've distributed, I'll set them equal. I'll set up my exponents equal. So it's 4 to the 3x minus 6. This is the biggest part that's going to be missed, that distributing. And it's 4 to the negative 4x, and negative 4 times 12 minus 48. My bases are the same, so I'm switching to setting the exponents to each other. and combine my like terms. I'm going to add 4x to both sides. I'm going to add 6 to both sides. And so x is equal to -6. All right, so that is exponential equations.